All right, so we're going to continue with properties of trigonometric functions, Unit 6, Lesson 3, and we'll finish this up next week, actually. So one thing that is helpful is if we know what the sign of each trigonometric function is in the four quadrants of a graph. So in quadrant 1, sine, cosine, tangent, cotangent, secant, and cosecant are all positive. In quadrant 2, sine and cosecant are positive. Cosine, tangent, secant, and cotangent are negative. In quadrant 3, sine, let me start that again. In quadrant 3, tangent and cotangent are positive. Sine, cosine, secant, and cosecant are negative. And in quadrant 4, cosine and secant are positive. Sine, tangent, cosecant, and cotangent are negative. So we could be asked a question like, if sine of theta is less than 0 and cosine of theta is less than 0, name the quadrant in which the angle theta lies. So in this case, sine of theta is negative because it's less than 0. Cosine of theta is negative because it's less than 0. So looking back at our previous slide and the values, the place where sine and cosine are both negative is in quadrant 3. So the quadrant would be quadrant 3. A couple of identities with trigonometric functions. One special type of identity are called reciprocal identities, because the trig function is equal to 1 over a different trig function. And there are 3. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. Another type of identity very similar are called quotient identities. And the quotient identities occur when we have a trig function divided by another trig function. So a little bit different from the reciprocals, where it's just 1 divided by the trig function. Here it's a trig function divided by a trig function. And the 2 quotient identities are tangent. Tangent of theta is equal to sine theta over cosine theta. And cotangent, which we can see from the reciprocal identities, is just the reciprocal of tangent. So you take the trig functions that make up tangent and you flip them. So we get cosine theta over sine theta. And we can use these 2 identities and these 2 types of identities to come up with some values for trig functions if we're given certain other values. For instance, if we know that sine theta is square root 5 over 5 and cosine theta is 2 times the square root of 5 over 5, we can find the value of the other 4 trig functions. Using the reciprocal identities and the quotient identities. For instance, to find tangent of theta, well, according to our property list, tangent theta is sine divided by cosine. So we'll take sine divided by cosine, or square root 5 over 2, square root 5 over 5, divided by 2 square root 5 over 5. And then we can use the idea of dividing by a fraction is the same as multiplying by its reciprocal. In this case, the square root 5's cancel, leaving us with a 1, and the 5's cancel, leaving us with a 1. So if we multiply straight across, we get 1/2. For cotangent, this is cosine theta over sine of theta. Again, rewriting the division as multiplication of the reciprocal. Square root 5's cancel, 5's cancel, leaving us with 2. I guess I should say that these leave 1s there. So you're still multiplying across to get 2. To find cosecant this of theta, this is 1 over sine theta. Or 1 over the square root 5 over 5. That would be the same as 1 times the reciprocal, which is 5 over the square root of 5. And one of the things we want to avoid is having that square root in the denominator. So I can multiply the numerator and the denominator by the square root of 5, giving me 5 square root of 5. Square root of 5 times square root of 5 is square root of 25, but the square root of 25 is just 5. And here we can reduce. There's a common factor of 5 that cancels, leaving me with an answer of the square root of 5. One more to do, and that is secant. Secant theta is 1 over cosine of theta, or 1 over 2 root 5 over 5. Again, we're going to change this to multiplying by the reciprocal. And now I need to rationalize. I need to get rid of that square root. So I have 5 times the square root of 5 in the numerator, and 2 times the square root of 25, which is just 5, that's in the denominator. The 5's cancel, and I'm left with square root 5 over 2. So there are the other 4 values for the trig functions, and the problem is done. So for your assignment, you'll be doing 2 things. One, telling what quadrant a given angle is in, just like our first example, and the other, given values for sine and cosine, find the other 4 values of the trigonometric functions. Please remember that you need to view this video before you can do the homework. Thank you. Have a great day. And I'll have more posted next week.